So this is a first video of a couple of videos of determining how to find the oxidation numbers, and also that leads into identifying your redox reaction. And once you have understood that, then we can actually look into balancing reactions with oxidation numbers and half reactions. So in order to do any of that stuff, we need to know how to determine oxidation numbers. So what are oxidation numbers? Basically, they're just looking at the charge of the atom. And when we're looking at the charge of the atom, it's basically looking at if any electrons have been lost or gained. So anytime if you have something that has a negative charge, then you have gained extra electrons to make it negative, or if you have something positive, then you have loss of that. So the method I'm going to show you is basically the bottom-up method. What that means is that I'm going to write out the oxidation number of each element or of the atom below the bottom, below the compound. So that means that this is the oxidation number of the atom, it's below, and this is the total oxidation number determined of the number of atoms that we have. So an example of this is that in Cl, the oxidation number has a charge of -1, but because you have two of them, so you're going to be multiplied by 2 to give you a total oxidation of -2 for the chlorine atoms. And to balance all this stuff out, we want this to, because this is neutral, it equals to 0, like all this equals to 0, this has to be +2. And then because I only have one calcium atom, this atom has +2. So right now you might be wondering, oh, where did I get all those numbers from? So let's go over the rules to determine all of that. And these are the rules to help you assign oxidation numbers. I know it's a lot of different rules, but if we were to look at individually, it's actually pretty straightforward. If you look at the first one, this is the oxidation numbers all on combined elements is 0. Basically, if anything that's a metal solid, potassium solid, or any diatomic molecules, you will have it as a 0 oxidation number, and that's it. And the second one, it says the oxidation number of monoatomic ions equal the charge of that ion. So that means that if you have fluorine, that's -1, or if you have Ca and it has a +2, that's a +2 charge. So if it has a charge indicated, that's the charge that you have. And then the next two is pretty straightforward. I think at this point you should know the charges of alkali metals and alkaline earth. They all have a +1 or +2. One is aluminum, has a +3, if you're wondering. Fluorine, like this one, it's the most electronegative, so it's always a -1. Here are your two different exceptions. Hydrogen is usually a +1, but unless it is bonded to a metal such as a hydride. So this is a metal hydride. And when you have metal hydrides like that, then your hydrogen actually has a -1 charge. This will give you -2, +2, +2 for each magnesium and hydrogen. So that's one thing to keep in mind, is that if your hydrogen is with a metal hydride, then it's a -1 charge. Another one exception is that oxygen, you always want to start with oxygen, has a -2, but there is an exception. If oxygen is in the peroxide, basically, if you remember it to be your double-double, that means that your first element has 2, the second element has 2, double-double, then you would have oxygen being -1. So one example is H2O2. You notice that's double, 2 and 2. So this will have 1 times 2 is -2, +2, +1. That's another exception. Then last two, this is looking at the neutral compound. So anytime you have a compound that doesn't have a charge, then it has a sum of 0. So everything you add up has to be 0. And then the last one is your polyatomic. If it's like NO3 nitrate, it has a -1 charge. That's the overall charge. So everything of this has to equal to -1. So instead of equaling to 0, it has to be -1. So those are some of the rules. Once you have done many of these ones, all these rules kind of just stick in, because it's basically just the charges. So let's look at some examples here. We have a bunch of different examples here. Let me just kind of organize these. And again, I'm going to do these in a bottom-up method. So I'm going to put the oxidation numbers at the bottom and then put the total number at the top. So to start off with my SO3, let me just write this. This is for my atom, and this is for the total. So for the bottom, for this one, you want to start off with oxygen as a -2 because I have 3 of them. That gives me a total of -6. And this is a neutral one, so I'm going to balance it out with a +6, giving me a +6 for each individual sulfur atoms. The next one is SO2. So start with here again, -4, -4, +2, and +2. And you probably notice that some of these should have a charge, but for this one, we're not going to look at that. S2F10. Fluorine is the most electronegative, so it has a -1, and because I have a -1 here times about 10, I have -10. And then because of that, then I'm going to have a +10 on this side, and you might be wondering, oh, 10 divided by 2, that's going to give me +5 for each sulfur. And then let me move over the NO2. So NO2 start off with oxygen again, -2, and then times about 2 to give me a -4. Balance this out. Nitrogen is going to have a +4, and because I only have one nitrogen, so I have a +4 as each single one. And moving on to this one, chlorine has a -1, and then this will have a 4 of them, so I'll have a -4. Now, because this one has an overall charge of a -1, this plus the manganese has to equal to -1, so this makes manganese to be a +3, because +3 minus 4 gives you a -1 overall charge. That's how you do it with the polyatomic. Moving on to this one, S2O Cl4, -1, -4. My oxygen is in -2, so I'm going to put -2. So -2, -4, this gives me a +6, divided by 2 is +3. And then moving on to here, hydrogen, this one is not with a metal, so it has a +1, and then this is +10. And then oxygen is -2, -2. So what I have right now is an overall of +8, giving me a -8 here, and it gives me a weird fraction of -8/5. This is not very common, but for this example, that's what it is. And second last one, here I have a polyatomic ion. This is NH4NO3. Two ways of looking at this. We actually can split this into the left or right parts. So this side has a -1 charge, this side has a +1 charge. And we know hydrogen is a +1, so this is going to be +4. Nitrogen is going to be a -3, -3. And then for this one, -2, -6, and then +5 to make it overall charge of -1. And that's how we do it. And the last one for nitrite, -2, -4. This one has an overall charge of -1, so nitrogen has a +3, +3. So after practice, oxidation numbers is actually not too bad. It's just getting used to the method and getting used to the charges and remember the exceptions. So hopefully this video has helped you. So see you later.